Hello everyone, I'm Sumana. I'm currently pursuing my graduation in Information Technology from Gokaraju Rangaraju Institute of Engineering and Technology. I'm here to present my mini project which I worked on along with my teammates Harita and Bhavani. I would also like to express our heartfelt gratitude to our project guide, Dr. Srilalita ma'am, for her support and guidance. Our project, Course Attainment Analysis, using Bloom's levels, focuses on analyzing the course attainment of students through the lens of Bloom's taxonomy. Examinations serve as a crucial assessment of students' knowledge and skills, but it is also equally important to ensure that these exams effectively evaluate students' understanding and application of the course material across different cognitive levels. Bloom's taxonomy is a framework developed by educational psychologist Benjamin Bloom that categorizes learning objectives into different levels of cognitive complexity. It provides a structured way to assess and measure the depth of understanding and thinking skills required for learning. Bloom's taxonomy consists of 6 levels, starting from the lower order thinking skills to higher order cognitive skills, namely remembering, understanding, applying, analyzing, evaluating, and creating. Before we discuss our proposed system, let's briefly explore the existing system. Earlier, people worked on Bloom's levels by automating the prediction of Bloom's level for a given question by identifying significant keywords to determine a suitable cognitive level, but it lacks contextual understanding. Using keywords alone to determine the cognitive level may not fully reflect the context and complexity of the topic. Our proposed system aims to address the limitations of the existing system by using natural language processing and machine learning. We will determine the Bloom's level and visualize it using a pie chart. To better understand the scope of the proposed system, let's look at the activity diagram. The flow of work from one action to the next can be seen by using the activity diagram. It emphasizes the presence of flow and the sequence in which it takes place. First, we start by taking the question paper as input, which is in the form of a document. Next, we process the text of each question using natural language processing techniques. This allows us to identify and classify the Bloom's level associated with each question. To achieve this classification, we employ the support vector machine algorithm, a powerful machine learning technique. Once we have determined the Bloom's level for each question, in order to facilitate comparison and interpretation, this information is represented using the pie chart. Students' learning outcomes and their command of various cognitive skills are comprehensively viewed through the visualization of course attainment for each Bloom's level. Next, let's look at the use case diagram. A use case diagram illustrates the high-level functionality and scope of the system. These diagrams also show how the system and its actors interact with one another. The system architecture is a conceptual model that defines the organization and operation of numerous components and subsystems. The data flow diagram illustrates the flow of data within the system. It shows how information moves from one component to another, highlighting the processes and transformations that occur along the way. By analyzing the data flow diagram, we can gain insights into how the system handles data and performs the necessary computations. Moving on to the next point, we have sequence diagram. The sequence diagram captures interactions between different components or objects in a chronological order. It showcases the sequences of messages exchanged between these entities, providing a clear understanding of the system's behavior and the order of operations. Without further ado, let's progress to the implementation of our project. We utilize Flask, a Python web framework along with HTML and CSS to build the front end of our application. Flask provides a robust and flexible foundation for developing the user interface. The heart of our project lies in the machine learning core. We utilize techniques such as TF-IDF vectorization and classification to analyze the data. And we achieved an accuracy of 74.146% using support vector machine algorithm. Now let's move on to the execution of our project. To initiate the analysis, we provided an option to upload the question paper. Once the question paper is uploaded, our system processes the text of each question to determine its corresponding Bloom's level. By applying natural language processing and machine learning techniques, we classified each question. The culmination of our analysis is the generation of a pie chart. This chart visually displays the distribution of Bloom's level across the exam questions. It offers a clear and concise summary of the percentage of questions falling into each Bloom's category. And we calculate the weighted average percentage of course attainment for each Bloom's level. This metric provides valuable insights into students' general performance and comprehension across the various cognitive domains represented by Bloom's taxonomy.
Ultimately, our project, Course Attainment Analysis Using Bloom's Levels, aims to enhance the teaching and learning process by providing meaningful insights to students' mastery of course content and alignment of assessments with the desired learning objectives. Thank you.